He is actually one of the best professors I've had.
Okay, let's get started. Okay, this is the last class before spring break. We're all happy about that. So right now you're working on the clients for the client for the bottle game. It's due tomorrow or Saturday, late day. I thought I'd demo mine here. Not that it's particularly artistic, it's very utilitarian. But if you're having trouble wondering what it ought to look like, it's got to have like a grid and some buttons and some text boxes, which that one does. Does anyone have a working server here that wants to join the game? Okay, help me out. Soy. Dough. Log.
Why is it not working?
Wait.
Is ye a word? Y-E-E?
Yes.
No.
Did you put yes? Did you put yes yet?
That did. Yes. What the heck am I playing against here?
Did you do yes?
E got eyes.
Cleo.
Okay, do you know whoever's playing against me? Are you first of all aware of the rules of Fobble? I guess the more important question is your board laid out. Right, so the letters when they come across, they're in this order. First row, second row, third row, fourth row. And I guess if you don't, if you like did this row and then this one backwards, then you wouldn't be playing the same game. So just at least be sure that. Okay? So that's the idea, and then I could play another game if I wanted to, just by clicking on the join game. Okay? So are there any questions I can answer about the assignment or problems you're having? How's it going? Good? Okay, there was a question on Piazza right before class that had to do with what kind of loop to use while you're waiting for someone else to join the game. Or you also need to repeatedly, while the game is playing, you repeatedly get status and update the scores. So you don't want to loop, you want to use a timer. And with a timer, you can just register a delegate, and you can arrange for that delegate to be called every second. And then it just gets called every second. Now, there's a choice of timers. There's at least two. The one you want to use is the one that's part of the Windows.Forms namespace, because in that timer, the delegate's called on the GUI event thread. Why is it important to have that delegate be called on the GUI event thread? Yeah.
Always get a cross-thread exception.
Right. We said otherwise you get a cross-thread exception. So the idea is your delegate being called on the GUI event thread is going to run. It's probably going to manipulate the GUI in some way. And to do that, you need to be running on the GUI event thread, or you have to use the invoke method to get out of trouble. If you use the other kind of timer, you're going to be having to calling invoke all the time, and that's kind of a pain. So just use the one that's built into, that's part of one of the GUI things. So system.windows.forms.timer, I think is what it is. One mistake I saw yesterday was a group that every time, it's roughly like this, every time their timer ran, every time their delegate was called, they would re-add the delegate to, rehook the delegate to the event. So timer would run, rehook. Timer would run, rehook. So what happened? Right. I think their model was that every time it ran, it was somehow unhooked, and you had to re-register with the the timer. But no, if you keep hooking the same delegate over and over again, it's going to get called. If it's hooked 10 times, it'll be called 10 times every second. And if each of those 10 times rehooks itself, the next time it's 20 times, and then 40 times, and it doesn't take long before you bring the computer to its knees. So, yeah. You just need to hook once, and then you can start and stop the timer as you like. Yeah. Anything else going on? Yeah?
Is it okay to not use a timer and just get time from the server?
No, I'm not using the timer to say what to. I'm not using the timer to figure out how many seconds have elapsed.
Okay.
I'm using the timer precisely because I'm getting the time from the server.
Oh.
And I want to ask the server every second, what's the current time and score?
Okay.
What's the current time and score?
How long to wait between those calls?
Right, so yeah, it's kind of a waste of a thread to block the thread for, to have a thread that makes the call, blocks for a second, makes the call, blocks for a second. It's cleaner just to use a timer to fire off the delegate every second. Yeah?
So when we're pulling information about the player data, like player 1 versus player 2,
Yeah.
we came across an issue where we were wondering if that, like if we had to pass some sort of token in order to make sure that we were talking about the right player when we're pulling the scores for the players.
Well, anytime that you are getting information about a game, you got to pass in the game ID and also your user token. And I guess you need to pay attention to, figure out who player 1 and player 2 are. You can compare the user token that comes back with your user token. Okay. All right. Any other questions, problems? Yep.
In the documentation for the assignment, you mentioned that you put an at in front of the nickname as opposed to do a 10-second delay.
Mhm.
Keep getting a 403 error though.
Okay, you don't put the at in front of the property nickname. The value for the nickname would be like @Joe.
Yeah, like what you're entering, like say Mark, answer that my question, and then you get
Well, let's
For me.
I'll do Joe and register. And what ought to happen is it takes 10 seconds before it, so the server just delays 10 seconds. So I don't know, the server's doing the right thing. I have to look at your code to tell what's going on. Yeah.
How did you do that loading animation in the corner? That's cool.
All right. How did I do that loading animation? Yes. That's just it's a GIF. What's the word? An animated GIF.
Okay.
So it's just a single GIF file, so I'm just displaying that image in the upper right-hand corner. And when you display a GIF, an animated GIF, it just displays a sequence of frames over and over again.
Cool.
Yeah, so it's a simple way to do that. Okay, yeah.
Is it fine if I have the user clicking buttons to make the word instead of entering in a text box?
I mean, like clicking in here?
Yeah.
Yeah, it's okay.
All right.
Yeah, you can make up your own interface. Be even cooler if you somehow, like they click on it, you color it so you can tell where you've been.
Oh, I've already done that.
Okay, very cool. I will say the group that had the problem with hooking multiple delegates had a stunning GUI. Just looks so pretty. It's really a high-end GUI, so that's always good to see that. My GUIs never look very good. Anything else? Okay, well, your next challenge, you come back from spring break and you'll be writing a server, at least part of the server, that this thing is using. So I've got to get you ready for that. We started working on that on Tuesday, but because of the projection problems that we had, it was kind of an uneven kind of lecture. So I want to revisit that. And here's what I've done. Where do I want to go? No. What I've done is in the examples repository now, there is a project called Boggle Service. So I was telling you last time that you need to take my example, my to-do list service example, and refactor, rename things by refactoring and get a starting point for your service. But, then I started thinking, that's stupid. Why don't I just do the refactoring and give you the starting point? And then I discovered I had the same idea last year, and the refactoring starting point already existed. So that will be given to you all. It's in the examples repository right now. I'll put it on branch, or whatever, the PS, which one are we on? PS9? It'll be on the PS9 branch eventually. And I don't know if you can, I don't know how to blow this part up, but you can see Boggle Service. There's a bunch of stuff built in. There's Boggle Board. So Boggle Board contains code not related to networking and not related to REST. It's code, it provides some functionality you'll need to make the service work. And the main thing it provides is a representation of the Boggle Board, and it has methods like, the key method is this word legal? So it gives you a way of testing whether a word that a player has played is legal. So that's, you won't have to worry, that's a graph searching algorithm you need to use there. So I provided that. So be sure you don't try to duplicate that functionality because you don't realize it's there. It's sitting right there in boggleboard.cs. Then we have boggleboard.svc, that's the actual service. That's the REST part. We have datamodels.cs, which is a place where declarations of the classes that are being passed in and out of the REST service can be declared. That's just the name I picked. Dictionary.txt is a text file that contains all the legal words, as far as we're concerned. iBoggleService.cs is the interface of the REST. It's the REST interface. Index.html is the API. And then there's another project called Boggle Service Tests, and we'll look at that as well. So one thing you'll be doing is you'll need to test your server, of course. And while it's difficult to test a client, a GUI client, it's relatively easy to test the server. You just write test cases that make REST calls. So you sort of put the kind of client code you have in your GUIs, you put them into a test case, and it tests the server running wherever. And the cool thing about these test cases that you have to write is you've got a way to debug them. You've got a way to debug your test cases. What is that way? You have to write some test cases that determine whether or not a remote service is running correctly. And you're ultimately interested in testing your service. But how can you test your test cases before? Yeah?
Run them against your service.
Right. You can run them against my service. You can point them anywhere you want, so point them at my service. And assuming my service is correct, you can debug your test cases that way. And then, once you've got confidence in your test cases, you can turn them on your server. So this is sort of something that really wasn't generally possible before, but now it is because you've got a reference server out there to deal with. So we'll talk about that as well. Let's start. The place to start is to actually look at the interface. So I'm going to go to iBoggleService.cs and I'll blow that up. So this is where, remember, you declare all the endpoints that your REST service provides. Now, it's your problem to declare the ones that need to be declared for your service. I've just declared some just for us to experiment with. So these aren't useful. The first one's useful. The rest are just demos. So that first one is a service. So if you do a GET request and it's /API, I've implemented that endpoint so that it sends back the API. It basically sends back that index.html file. So that's handy to use in. Okay? Here's one right here. Look at that and tell me, we talked about this last time, what does the combination of these two things tell you? How would you use this service? What kind of thing would you get back, and what would you expect from it? So let's start with, how would you invoke it? Yeah?
You need the word $index thing as part of your URL.
Okay, well that's part of the URL. The URL would end with index equals and then some number.
Yeah.
What would it start with?
Server address.
All right, so the server's running somewhere. In this case, it's running on my, yeah, it's running on, I need to start it. Did I start it? I think I started it. I think it's running on this computer. If it's not, I will have to start it. Oh, this is it. Okay. So it's running on my local machine, so it'll be running on http://localhost:60,000, because that's just how I configured it. So that's how the URL will start. What will come next in the URL after the domain name, the port?
The SVC.
Word.
The boggleservice.svc, that's the name of the service. Then a slash, then word question index equals something. Okay? So what will happen when we invoke this URL? In terms of what will the service do? Well, just talk in terms of what you see right here.
Get the number from where n is, then look into your, then put it inside int n inside the word at index.
Okay, so the code will automatically be generated, which pulls this int out, parses it to an int, and passes it as a parameter to word at index. That word at index method will run and return a string. What will happen to the string? Yeah.
Gets sent as a JSON object to the caller.
Well, it gets sent back in the body of the response, and it's turned into JSON, but in this case, not to an object. It turns it just to a string. So basically, nothing happens. It just gets sent back as a string. Because what's being returned is not an object, not a list. What's being returned is a string. So a string goes back. So just to show you, let's run this. So I'm going to start the service. Start it. Let's try again. Okay, so my service should be running at this point. So there's really nothing to see here. If I go back here, and let's say I want to invoke it, here's a place where I invoked it. There's my get. So let's see. Localhost 60,000, that's just where the service is running locally on my machine. And when you're playing with it, it'll be port 60,000 on your local host. /boggleservice.svc /word question mark index equals 8392. So we're asking for the 8392th word in the dictionary. And we just set that up. We make it a GET request. There's no body. We click send. So it goes off, contacts the server, and back comes a response. And if we go down to the bottom, we can see that what came back was that string, arraignments. So that works. You know, if you change this number here, 64, send, back comes a basing. Okay? So easy to try it out. So let's go back to, let me stop it from running. So here we are back at iboggleservice.cs. What do we need to look at to see what's actually happening when we do this invocation? We see that there's code being generated for us that automatically hooks the two things up. It takes the URL and turns it into a method call, and then takes the method call that comes back and turns it into a response. What's happening in between? Where do we need to look to see what's happening in between? What's actually doing the computing? Yeah, so this one here, boggleservice.svc.cs, contains the actual implementations of these interfaces. I'll leave it here. So there's this helper method, setStatus, that sets that's how you set the response code. And this is the word at index method. You know, if n is negative, it sends back a forbidden response. Otherwise, it reads in the file, it goes to the file, it looks for the nth string. If it finds it, it sets the status to OK and returns it. Otherwise, it sets the status for forbidden and returns null. So the only thing that has anything to do with REST in this method is what? I mean, look at the parameter list. It's just a method that takes an int, returns a string. There's no URL, there's no HTTP request, there's no HTTP response. What's the only clue that this is doing something that has something to do with rest? Yeah.
Set status.
Set status. So except for set status, this is just straight old, CS 1410 level code. It's just a simple file process. So you get the plumbing set up back in that interface file, then you're just coding it. Except before you return, you need to set the status. That's the only thing you got to remember to do. So really not that hard as long as you get this interface set up right. So what I encourage you to do when you get the interface set up, you're going to have to add whatever 5 or 6 endpoints to it. Add one. Make sure that works. Test it out in the advanced REST client before you add the next one. That way, if you screw one up, you'll know when. If you add all 5 and then something messes up, you don't know where the problem is. So that's just common advice. Just do things one at a time. Get the interface file right, and then the rest is just bread and butter kind of programming. Let's try an exercise here. I want to have a method that takes, it's like webget, except it takes 2 parameters. It takes an index and a count. And instead of returning one word, it goes to the index, like it goes to the nth word, and then returns the m words that follow that. It returns a list of words instead of a single word. So one parameter says where to start in the dictionary file. The next parameter says how many words to extract. All right, suppose we'd like to have that. How would we set it up in the interface file? What do we have to add to the interface file to make it so that the right method will be called automatically when a URL is used? I'll start by copying and pasting here, since this is at least a starting point. Okay, what do we need to change? Okay, so right here we got to say index equals n, and let's see, count equals whatever. So we just change our URL so that the query string part of the URL has 2 things, count and index. Now what? That describes the form that we want the incoming URLs to have. Yeah?
Add a parameter on the
All right, so now it'll take 2 parameters, n and m. And of course we're going to have a different method. We'll call it words at index. And what about the return value?
Object.
We're not going to return a string. What are we going to have it return?
An I list of strings.
An I list of strings or a list of strings. I think it would work either way. Let's try that. Okay. So there we go. We just need to define words at index to do this operation I just described. And then it'll automatically be called when it's supposed to be, and whatever list of words it gives back will be automatically shipped back in the body of the response, encoded as a JSON list, JSON array. Okay? So what do we have to do now to close the loop so we can test this thing out? Yeah?
Implemented in the Boggle service class.
Right, we need to implement words at index. So there's word at index, that's the one I was just showing you. And lo and behold, I wisely implemented it for class. Rather than try to stand here and type this stuff. But basically, it just checks the parameters. If any are negative, it says forbidden and returns null. Otherwise, it loops through the details don't matter, it loops through the dictionary and finds, when it gets to the starting point, it takes the next m words. And then it just returns, in the end, it just returns the list. So it's just, except for the set status, it's just a method that takes in some numbers and computes a list and returns it. Okay? You don't have to have any mention of JSON anywhere, because it's going to be automatically serialized. Okay, let's see if this works. I haven't tested the method there, so it may well not, but we'll see. Whoops. So is this it here? running. We'll go here to the advanced REST client. So to call it now, we need to say words index equals 64, let's say. What will happen if I run that? It should say forbid. Well, we're not providing a value, so I'm not sure what will happen. Internal server errors.
I don't think we changed our URL for words.
Say it again.
I don't think we changed it for words.
Well, let's see what the error says anyway. You're right. It says URI template table does not support multiple templates that have equivalent path. Okay? So it's saying that I screwed up the configuration back here in the interface file. And it needs to be something unique. Oh, can't edit while code is running. I need to have a unique URL for each of these things. So that's just an example of where we didn't find out the problem until we actually used it. That's why I say add one interface at a time. So you know what the error is referring to. Okay, so fire that up again. And I guess rather than try out an error case at first, let's try one that's supposed to work. Count equals 100, let's say. Okay, so that should work unless I have a bug in my original code. Okay, it says 200, okay, and there the words all came back. Now that's sort of the pretty version. One of these will give us the raw response. So the raw response was just a JSON list. A JSON list of strings. So again, easy stuff. As long as you can get the interface configured correctly, it's not that hard. Let's do one more. Now this is kind of convoluted. The idea is you're given a list of objects. Now, I think it might be easier to illustrate back here because I do have a call to it saved here. That's not it. It's this one. Okay, it's called max. And if we look at the body, okay, that's what the body will look like when we call max. So it's going to be a put request. It's going to include a bunch of a list of objects. Each object will have a word property and a value property. And what the method is supposed to do is find the word, find the word that has the highest value that is also in the dictionary, and then return the entire pair for some reason. Okay? So what should it return in this case? It should return the hello 15 pair, because only the higher value one is not in the dictionary. Okay? So that's just contrived so we could have something to declare. So let's go back and declare it. So this is just one I copied so I can remember the syntax. One weird thing to notice is that you do gets differently than you do everything else. So for gets, there's this web get thing that just has a URL in it. For web invoke, you put the method and then the template. All right, so I just said it would be okay, what do we do? What should we use as our template? Okay, we might as well call the method, have the URL be max. Okay. There are no parameters coming in the URL, so nothing to do there. How do we, how do we declare the method now? Okay, it's going to return some sort of object, and in fact, what we want to have it return is an object. Let's invent something called maybe text value pair. How about that? I've already declared it, so it'll save you some time. So a text value pair is this. Text value pair is just a method, is just a object, a class rather, with two properties, text and value. One's a string, one's an int. All right? Good. So it's going to return that, and then we got to call it something. I don't know, I'll say max pair. How about that? And what should it take as parameter? First of all, where does the parameter come from? Since this is a put, there'll be a body. Whatever the body is deserialized into a C# object of some kind and passed as a parameter in max pair. Now, when it's deserialized, what will it be? What kind of thing will it be? I showed you the example back there. I don't know what would happen if you use dynamic here. I haven't tried. So it's a list of text value pair objects. Okay? So that's just saying, when a put request is made to this URL max, call max pair, deserialize the body of the request and pass a pair. So the rule is, you can have exactly one parameter that isn't named, doesn't appear in the URL. And if there is such a parameter that's not named in the URL, it gets its value from the body. Right? So the body will be a list of things, it will be deserialized into that. The method will be called, the method will return a pair, and that will be serialized and sent back. All right? So I told you I already did text value pair. So I did a method here called max values. What did I call it? Max pairs? Max pair? Okay? So it is going to be reading, well, the one thing I forgot to do was do the set status. So hopefully I've written my loop correctly. I don't have any error checking. I forgot that too. So in theory, this should work. It'll compute the best pair, and it'll return it, and everything will be serialized and deserialized appropriately. Okay? So before we go run it, you got a question?
Yeah, do you have a case mismatch between here and the interface?
Yeah, I was noticing that. I'm going to have to change my call, because here I capitalized the property names. There I didn't. I think that probably makes a difference. Yeah?
So do you only need to specify like successful status codes?
No, you need to, these other ones that I did earlier, I did set status forbidden.
Okay.
You just set the status to whatever, you set the status before you return. So status codes other than OK, I can think of them as exceptions, if you will. Yeah?
Would you be able to put in a number instead of like okay or?
Let's see what set status. Set status expects an HTTP status code, so we could try. Maybe it has a cast. No. You could change set status, take a number. Just make an overload that uses a number. All right, let's try it out. This is what I was saying is, unfortunately, I changed my mind at some point. Okay, so there's our JSON. It's going to the max. It's a put. So if I didn't have any problems in my method, this should work. I'll give it a 50% chance of working. Zero. Ah. Okay, that's a common mistake. The requested URL cannot be reached because service isn't running. Okay, so what do I change? I need to change the interface. Thank you. Okay, we'll run this. Yay. What am I doing? I'm going here, and I'm going to send it. And it says OK, and nothing to display. Oh, that's bad. In fact, its display is spelled wrong. Wow. That concerns me. The response code is 200, but nothing to display. Wow, I wasn't expecting that. So let's debug it. It says it returns a text value pair. Let's just make sure we really are. I returned best pair right there. I set best pair to null, so I wonder if what's happening is I'm returning null from here. If words contains pair.text, so here I have read all the words in the dictionary. If it contains pair.text, then I check if best pair is null or pair.value is greater than best pair.value, best pair equals pair. I suspect I've screwed something, I know I've screwed something up. Yeah?
Sounds like if you pass it three things, it'll choose a trick. You know what, never mind.
Okay. Whatever can we do to debug this? What will you do if your server doesn't work? Yeah.
Breakpoints.
Set a breakpoint. Yeah. This is just a program. So I'll set a breakpoint. Let me start with. Yeah. I'll wait. Well, I'll set up above. We'll set a breakpoint at the beginning of the for each loop. So I will run this. So you can get a little bit confusing, especially on a laptop with limited screen space. So go back to here. I will send it. And here we are at our breakpoint. And let's see what we got. We got words, which has 178,000 things in it, so it's got all the words. We're about to loop over this list of pairs, which has 3 things in it. So let's see. We go here. We pull out a pair, and that pair is that. Okay. We step over. What? So it's not finding the, oh, I know the problem. It's not finding the word in the dictionary. And I just realized why. Every word in the dictionary is in uppercase. So it's good that I made that mistake so that you don't have to. So now we'll capitalize the word before we look it up. Let me restart this now. Go to this guy. So what was happening is it wasn't finding any words, it was returning a null list, and that resulted in no response body. Okay. Object reference not set to an instance of an object.
You can't do two
It's
upper.
not
Yeah,
pair.text,
no.
String to upper.
Well, pair.text is a string.
But if it's a
But it's
null,
set to
you
null.
can't
You
use
see
two
the
upper.
values at the bottom.
Best pair is null.
It's because the query, it calls it word, and in the class it's called text.
Oh. Okay. Another inconsistency here. Right, it's called text, it's called value, but when I call it, yeah, okay. Oops. Okay, we got that. I got to make sure that my server is running. I forget how I left it. I'm going to start it and restart it just to be safe. So this is very, this is what you're going to be doing, is solving problems like this. And the thing to remember is, you've got the full power of Visual Studio at your disposal. You can set breakpoints, you can debug like I have. And now I do a send. And I get another exception, and I give up. Let's take a break. All right, let's get going again. So, as often happens, I realized my mistake right after we stopped. I had declared text and value to have getters but no setters. And I think my thinking was, my code doesn't do in the settings, so I just won't put setters in. But the code that's deserializing the objects is using the setters to create the objects. And it was just quietly, it didn't throw it eventually got an exception, but it didn't tell me the problem when it was deserializing. So once I defined the setters and reran it, I get an OK, and back comes the winner. Okay? So it's, you still got to solve problems, but just get the interface right, and the rest is, I'm not going to say it's trivial, but it's just the kind of programming we're used to. That's the way to put it. Okay, so that's building a service. So you'll be starting from what we started at today in order to get going. So you don't have to do any of that configuration. Are there any questions I could answer about that before we look at what you'll be doing as far as testing is concerned? Yeah?
Will you have this assignment published today?
Yeah. I'll put this up after class. Yeah?
Going back to that interface, why didn't we put the parameter in the URL again? Or specify a parameter?
So back to the interface right here. Why did we put the parameter here in the URL?
The one below the text value trigger, or the max pair method.
Okay, so tell me your question again.
In the web invoke,
right?
For the URI template, why didn't you specify a parameter?
Well, you're limited in having what you can put into a URL. We could take the list of words and turn it into a string and URL encode it and add it to the URL. But there's a character limit on how long a URL can be. And so typically for posts and puts, the information you need to pass is too big to fit in the URL. So you don't try, you just pass it in the body. Now, you can do both. I know it failed last time when I tried it, but we could do something like this. We could say max slash, again it's running. I could, add a parameter here and add a parameter down here. And then go change max pairs definition to expected integer. Now it'll get in from the URL and pass it as that parameter, and then this from the body and pass that. And that's actually something you need to do in the Boggle server, because the URLs, they're endpoints like that, where some of the information is in the URL and some's in the body. Like game ID is often in the URL. Any other questions? Okay, now, the problem, of course, is that most of you won't start on this for approximately 2 weeks. And you'll have forgotten all this because spring break's in the middle. It's the first time I've taught this course where spring break fell in the middle of this, fell at this point. It's always been a week earlier. So, what can you do? But I can answer more questions next time I see you. Okay, so that's the service. Now I need to test the service. And as usual, we'll be grading it with grading tests because it's easy to do. So let me show you what test I have here. Okay, and it's really not that big a deal to do the testing, like I said, because you just write code that makes assertions. Well, what's going to be different about this than other unit tests you've written? Let me get your answer over there.
Oh, you have to start the program in order to...
Right. You got to remember to start the server. You got to fire up the server, then run your tests, and then, probably in between batches of unit tests, you want to shut the server down so you get a clean start. Because the way we're writing the service this time, the data is not being saved in the database. So every time you restart the service, it starts with a clean slate. Now, you can do it that way, or I have code in here that automatically, before the unit tests run, it starts your service, and then when the unit tests in, it shuts it down when it works. But this code, in my experience, is kind of flaky. I tried it yesterday, and it still seems to work. But essentially, there's this class initialize thing. This is code that's run before any of the unit tests, and what it does is it just does what's necessary to start the service. And I guess we should look at it and see, is there anything machine dependent? Yeah, I think if your code is structured like mine, the project structure is the same. This will start your service, assuming, and then when it's all done, it stops it. So if that doesn't work for you, don't use it. Just comment out you can comment out the class cleanup and the class initialize, and then you just start and stop manually. It is handy when it works. Okay? So when I do my unit test, I got to have an HTTP client, and so I have a class you're welcome to use called REST test client, and you can create an HTTP client to communicate with your server with that URL. So it's looking for a server running on your machine that's listening on port 60,000. And that's the beginning part of the URL. And then the test had to provide the rest of the URL. So there's that. Let's look at, here's the only test method I wrote. It's against that word method that we started with. So it says, so my test, that class I mentioned, the REST test client that I gave you, it has a method called doGetAsync. And you pass it a URL, parameters that need to be stuck into the URL in place of those numbers. So that 0 is a placeholder. The -5 will be stuck in there. So you call that. It's an asynchronous method, but asynchronous methods don't mix well with tests, because unless you're careful, the test could end before the asynchronous method completes. So when you call it, just say .result, and that stops until the asynchronous method produces a result. So anyway, we call doGetAsync. When we're done, we assert that the status code in the response that was returned is forbidden. Because that's what the URL, that's what the API said. It said if you give it a negative index, you should get back forbidden. So we're making an assertion about the status code. Then we try another test where we pass in 5. We make sure that the response code was okay, and that the word that we got back was AAL, which just happens to be the 5th word. I guess it's a word, a Scrabble word or something. The 5th word in the dictionary. So that's what it's like to do the testing. You're just making REST calls and asserting that you get the right response codes and the right data back. That class I was talking about, resttestclient.cs, is right here. And when you call every one of these methods here, so there's a way to create a test client, which is just a kind of HTTP client. It returns, it's asynchronous, but when you get the result, you get back a response object each time. So there's a method you can call for each type, for get, put, post, delete. It always returns a response object. And the response object it has a status property and it has a data property that's public. And so any response object you get back will always have a status property set. If there was any data returned by the REST request, it'll be deserialized and you can access it with the data property. So it saves you from, makes life a little bit simpler. So my code, you tell it what method to use, what URL to use, what parameters to use. It makes the call for you, gets back the response and anything in the body, packages it up in a response object and returns that to you. And then you just make assertions against that response object. And that's how you write tests. Now, what would a sort of a complete test, what would an involved test of your server look like? Your Boggle server, what would it have to do? You sort of want an end-to-end test that put the server through its paces. You'll be writing such a test, so what we'll have to do? Yeah?
Running multiple calls of different types in the same test.
Okay, you'll be making multiple calls. Let's put it this way. What did I do at the beginning of class?
Play
Yeah.
a game?
I played a game with my client. So if your tests are basically going to be playing games via the test. So imagine your test. You know, you're going to have simple tests. But if you want to test the thing end to end, you're going to need a test that does something like registers one user, it gets a user ID, registers another user, gets a user token. One of the uses one user token to join the game, uses the other user token to join the game. Starts playing the game by sending words. And then when the game is over, which you'll have to sense somehow, makes assertion, gets back, it makes sure the score is correct and all that. So as you're going through the paces, you make assertions that the right return response codes were given and so forth. But fundamentally, you're just writing you'll be writing tests that do various things to the server and make sure it works properly. One of those tests will probably be playing a game. Yeah?
How would we control like what board it generates so that you could send it specific words
Okay.
to score them?
That's a good question. Once the board is being generated, how do you generate words that are or aren't on the board? Okay. Any ideas? Yeah?
You pass in something as a username like you did with like the @ sign, and then you could have it generate a certain type of board.
Yeah, you could change your service so that there's some way to tell it to use a specific board. But then you're not really testing the service as deployed. Well, think about it this way. In your service project, I'm giving you the dictionary to use, and I'm giving you code that can determine whether or not something is on the board. It's a simple matter to take every word in the dictionary and check it. Given the board you get back when you make the service call, you can take that board and take every word in the dictionary, see if it's on the board or not. Now you got a list of words that are in the dictionary and a list of words that aren't. I mean, list of words that are on the board and a list of words that aren't. And then you just pick from those. At least that's what I do. Right? The only thing that's kind of fuzzy now that I think about it is, so you're going to be firing some words at the game. Right? You'll be sending words up. And then you got to wait a while for the game to end so that you can see if the right list of words are sent back. How will you wait a while? Let's say your game's a 30-second game. How will you wait 30 seconds to make sure the game is over after 30 seconds? Yeah, sleep would work just fine in a test case. If you figure you sleep for 30 seconds, and when you wake up, you check and make sure the game ended while you were sleeping. So that's what you're faced with. But you're not thinking about any of this right now. You're thinking about clients. I understand.
Spring break.
You're thinking about spring break. And you got client before spring break. Okay, now, this next thing's really bad. Because after you do the server, that's PS 9. You're doing 8 right now, so the server's PS 9. PS 10, you'll take your server, and you won't mess with the interface you'll find. You'll go and replace the back end. So that instead of storing your data as static variables, poor man's database that I said last time, you're going to store it in the database. And so to do that, you've got to learn about databases. And to teach you about databases, that's my job. But I think it would be absolutely ridiculous to try to start doing that right now. Because you've got your client to worry about, you've got your spring break to worry about. Then you got to build your service when you get back. Then you got to build a database. So anything I tell you right now, it's going to serve no purpose, I think. So I'm happy just to end here. We'll start with this after spring break. Have a good spring break.